All right, so has your doctor ever said that you have heart conditions and that you should only do physical activity recommended by a doctor?
No.
Okay. Do you feel pain in your chest when you do physical activity?
No.
In the past month, have you had chest pain when you were doing physical activity?
No.
Do you lose your balance because of dizziness, or do you ever lose consciousness?
No.
Do you have a bone or joint problem, for example, back, knee, or hip, that could be made worse by a change in your physical activity?
No.
Is your doctor currently prescribing drugs, for example, water pills, for your blood pressure or heart condition?
No.
Do you know of any other reason why you should not do physical activity?
No.
Excellent. Can you sign this and date it, please?
Sure.
At this point, the subject has been at rest for nearly 5 minutes. We will now measure heart rate and blood pressure. These measurements help us set a baseline that we can compare to the data taken during exercise. Once we start exercise, we will take measurements of the subject's heart rate every minute to determine steady state. Steady state is a point at which 2 consecutive measurements are within 5 beats per minute of each other. Once steady state is reached, we will take blood pressure and ask the subject's RPE, which is relative perceived exertion, and then increase the workload. Once the workload increases, we will have the subject go until they reach steady state again. Once they reach steady state, we will repeat the process of taking blood pressure and measuring RPE once more. We will continue this process until the subject reaches 70% of their heart rate max. We are now performing the treadmill test. We are starting the subject at a speed of 1.7 miles per hour and with a 10% grade. Heart rate will be measured every minute throughout the treadmill test. Once the subject reaches steady state, we will increase the workload. Steady state is reached when 2 consecutive heart rate measurements are within 5 beats per minute of each other. Our subject has now reached steady state. At this time, we will take blood pressure measurements as well as get an RPE measurement as well. As soon as we have taken these measurements, we will increase the workload on the treadmill by increasing the grade and speed. The increase in workload represents stage 2. The subject has now reached steady state. At this time, we are going to take blood pressure measurements as well as an RPE measurement. As soon as we have taken these measurements, we will increase the workload The new workload level will be represented as stage 2. The subject has now reached steady state for stage 2. We will once again take blood pressure and RPE measurements. We will then increase the workload of the treadmill. The miles per hour will increase by 0.8 and the grade will be raised by 0.2. This will represent the start of stage 3. The subject has now reached steady state for stage 3. We are now taking blood pressure and RPE measurements once more. The workload will again increase by 0.2% on the incline and another 0.8 miles per hour. This will represent stage 4. The subject has now reached steady state for stage 4. We are again taking blood pressure and RPE measurements. The treadmill incline will increase once again by 0.2% incline, and we will increase the speed by 0.8 miles per hour. The subject is approaching the 70% threshold for this test. Once the subject reaches the 70% threshold, that will represent the final stage. We are now increasing to stage 5. The subject's heart rate is being recorded every minute throughout this exercise. Blood pressure and RPEs are being taken at each increase, right before each increase in kilopond workload. We are now taking a recording of the subject's blood pressure during the first minute of exercise. We have now increased the workload to 1 kilopond. This represents stage 2. We are now increasing the workload to 1.5 kiloponds as the patient has reached steady state for stage 2. The 1.5 kilopond workload represents stage 3. We have now increased the kilopond workload to 2 kiloponds. This represents stage 4 of the exercise test. The subject has again reached steady state, and we are now increasing the workload to 2.5 kiloponds. Again, we must remember that the subject is trying to keep the cycle ergometer at 60 RPMs. It becomes more and more difficult to keep at 60 RPMs with the higher workload. The subject reached the 70% threshold of her maximum heart rate, which was 130 beats per minute. We have now reduced the kiloponds to no resistance, and the subject is now recovering. Here we have collected the data from the treadmill test that we performed. As you can see, we were able to get an approximate VO2 max based on the results we got, and she landed at 35.5 milliliters per kilogram per meter, which is average for a subject her age.
Using our data that we collected, we were able to plug our numbers into a standardized equation for the bicycle ergometer test, and once we were able to calculate her approximate VO2 max, we were able to determine that it would be 21.84 milliliters per kilograms per minute, but we deliberated as a group that this is unrealistic because there are many physiological factors at play that may have affected these numbers, such as the fact that she had a Red Bull for breakfast that morning, and other factors such as we also had, she completed that test almost immediately after completing the treadmill test, and her body may not have actually been fully recovered before starting the test. So we are more comfortable with our calculations for our treadmill VO2 max test.